Bismillah ar-Rahman ar-Rahim. This is teacher Iman explaining from chapter 7 integration, section 7-2 indefinite integrals, the applications of indefinite integrals. Let's start now by that idea, which is how to find the equation of a curve. We know from differentiation that the derivative of a function f dash of x is the slope of the tangent at the point x and y. By using the integration, which is the opposite operation for derivative, we can find the equation of the curve. Oppositely, if its slope function is given at a point, lies on it, exactly by using the following rule. To find the equation of the curve, you are going to integrate the slope of the tangent, which is the derivative of the tangent. Let's have some examples about that. The first example is number one. If the equation of the slope is given of the tangent to a given curve at 2 and negative 3 is 2x minus 3. That means he give you the slope. The slope equation is given. So you need to find the equation of the curve. So to find the equation of the curve, you need to do the opposite of derivative. You have to integrate by using that rule. Y equals the integration of the slope of this tangent. Now integrate it, which is 2x minus 3 dx. If you integrate it, you will add the power by 1 to get x squared over 2, cancel 2 with the 2. You will get x squared alone, minus 3x plus c. Now you need to find how much is c by replacing this 2 instead of each x and negative 3 instead of each y, which is satisfy the equation of the curve. Exactly like that. Negative 3 equals 2 squared is 4 minus 3 times 2 is 6 plus c. 4 minus 6 is negative 2. Take it to the other side. That will make it positive 2. Negative 3 and positive 2 will give you a negative 1. Now we got c. Can we write now the equation of the curve? Yes, we can, which is exactly y equals x squared minus 3x minus 1. We are done. In example number 2, if he can give you the derivative of the function f dash over x equals to 2x squared minus 2x plus 3 over x squared plus 5. How you gonna find the original function? He gave you the derivative, and he is asking about the original function of f if its graph passes through the point 3 and 7. So you need to do the opposite operation of derivative, which is integration, which is exactly like that. The integration of 2x squared minus 2x plus 3 over x squared plus 5. Integrate each. Here you're going to add the power by 3 and divide by 3 to get 2 over 3x cubed minus. You're going to add the power, which is 1 by 1 to make it x squared divided by 2. Cancel that 2 with that 2 to get x squared. If you're going to take this x squared from down to up, you will get negative 2. Add it by 1, you will get negative 1. Take it down, you will get a 3 over x. Now, if you want to check this one, derive it. As usual, when you are deriving a 3 over x, you will get negative 3 over x squared, and negative by negative is positive. Now, the integration of 5 is 5x plus c. Now, we need to get the value of c by substituting by x by 3 and y by 7. Exactly like that. F of a 3 equals to 2 over 3 times 3 cubed minus 3 square minus 3 over 3 plus 5 times 3 plus c. That all will give us equals to 7. 7 equals to 27 divided by 3 is 9. 9 times 2 is 18. Minus 9 minus 1 plus 15 plus c. Now try to calculate this all and take it to the other side. Subtract it from 7. You will get c equals negative 16. Therefore, you can write down the original function of that, which is f of x equals 2 over 3x cubed minus x squared minus 3 over x plus 5x minus 16. More examples. Now, if we want to find the equation of the curve that passes through the point 2 and 3 and the slope of its tangent at any point on it is given by the equation. dy over dx equals, which is the derivative, 2x plus 3 over 2y minus 1. Actually, to integrate it, you need to make a cross multiplication between them first, exactly like that. 2y times 2y minus dy times 2y minus 1 is 2y minus 1 times dy equals 2x plus 3. If you multiply by dx, you will get 2x plus 3 dx. Make these at the end. Make these at the end. Now you can integrate each. If you're going to integrate 2y minus 1, you will get y squared minus y. And if you're going to integrate 2x plus 3, you will get x squared plus 3x plus c. Some of you is asking, why we didn't write here plus c like we did here? Actually, if you're going to write it here and there, finally they are constant and you are going to commute them in one side and subtract them or add them. So finally you will get one constant, put it anywhere. The next step is we need to find c by replacing x by 2 and y by 3. Let's do it like that. Y here is 3, square it is 9, minus 3 equals 2 square is 4, plus 3 times 2 is 6, plus c. These are 10. Take them to the other side, which is 6. 6 minus 10 is negative 4, which is the value of c. Now we can write the equation, which is y squared minus y equals x squared plus 3x minus 4. The next example is if the slope of the tangent to the graph of a function equals to y over x. You can find now the equation of the graph when the slope is given. This means the derivative is given, which is passes through the point 2 and 2. You have to integrate it exactly like that. Here we can see that the slope means dy over dx equals to y over x. Now you are going to make x together and y together to integrate them. So you can't actually here make the normal cross multiplication. But you can take this, make a switch. Dx goes up instead of y, and y goes down instead of delta x. To make y's together and x's together, make a switch between up and down here and there. You will get dy over y and dx over x. You can't use here cross multiplication because you need to make y together and x together. Make a switch better. Now you can integrate them. This is an integration for len and this is an integration for len, if you remember. Now you will get len absolute value because len doesn't accept negative, and len x because also len doesn't accept negative plus c. And we said that don't write c everywhere. It is enough to write it in one side. Now you need to replace y by 2 and x by 2 even. X by 2 and y by 2. Exactly like that. Len 2 equals len 2. If you move them to one side and subtract them, you will get 0. That means C is equal to 0. And you can write it exactly like that. Len y absolute value equals to len absolute value of X. You can keep it like that, and this is enough. Or you can get rid of len by using the opposite operation of len, which is exponential. And finally, you can get that result. Absolute value of y equals to absolute value of x. We are done with our lesson. I hope you get it well. If you have any question, please don't hesitate to ask and write your comments. Share, subscribe, and do likes. Thank you very much. You are welcome.